Section 4.3 is about polynomial division. And what we will be doing in this section is taking polynomials, dividing them by another polynomial, and usually writing them in this form, which isn't as bad as it seems at first glance. So let's divide this polynomial. There's two division methods you're going to use, regular long division and synthetic division. So let's do long division first. And you set it up pretty much exactly like you would do if you were dividing numbers. Okay, so there I'm dividing my polynomial by my divisor. And you'll note that I've put in a 0x squared and a 0x just as placeholders. It's a lot easier if you do this. And now what I'm going to do is look at these first two spaces. And I'm going to ask myself what I need to do to this to turn it into that. And the answer is I need to multiply this by x squared to turn it into x cubed. Once I have my x squared, I'm going to multiply this entire polynomial through by x squared. So x times x squared is x cubed. 4 times x squared is 4x squared. Now your text says subtract at this point. I like to make it even a little bit simpler and do it in 2 steps. So the first step is going to be to change the sign on everything you've got and then add them together. Your first term should always cancel out. And then I'm going to bring down the next term so I have as many terms here as I have here. And then I'm going to do the same thing I did before. I'm going to look at this first one and now that one. And I'm going to ask myself what I need to do to this to turn it into that. And the answer is multiply by negative 4x. And now I'm going to multiply this entire polynomial by negative 4x. So negative 4x times x squared is negative 4x squared. And negative 4x times 4 is negative 16x. Change the sign on both of those. Add them together. And bring down the next term so we have as many terms down here as we have here. And now the same thing again. I'm looking at this term and this term. And I need to multiply this by 16 in order to turn it into 16x. So now I'm going to multiply this entire polynomial by 16. And 4 times 16 is 64. Change the signs and add them together. And we are done. Here is my quotient, which is this q of x, and my remainder, which is this r of x. So if I was going to write this operation in this form, I would have my polynomial equals the divisor times the quotient plus the remainder. Now there's an easier way to do this if you have a leading coefficient of 1 and an exponent of 1 on your divisor. And that's called synthetic division. So let's do a synthetic division problem. And we'll work the same problem. And what you'll note is I changed the sign on this 4, and I just took the coefficients of all of my terms. Again, remembering to put in the zeros. So now what I'm going to do is I'm going to bring my first term straight down. First term always comes straight down. Then I multiply it by whatever's here. So 1 times negative 4 is negative 4, and I put it up here. Then I add these together and bring them down. Next thing I do is multiply negative 4 times the negative 4 and put it back up here. So that gives me a positive 16. Add these two together. That gives me a 16. 16 times negative 64 is, so 16 times negative 4 is negative 64. Put that up there. Add them together and bring it down. And we have our answer, except it's not quite in the right term. We have to sort of reconstruct it. This is my remainder. And this, if you'll notice, has the exact same coefficients as this. So when we're reconstructing, that's my constant, my x squared, and if I had more of them, they'd be x cubed and so forth. So this actually represents x squared minus 4x plus 16, which is exactly what we got for the quotient up here. So a little bit easier to do it this way, and once you get this pattern down, it becomes very simple to do. So let's try another one using synthetic division. So I'm going to set this one up just like this and put in the coefficients. And I'm not missing any spaces, so I don't have to put in any zeros. First term comes straight down, gets multiplied by negative 6 and put up here. And these get added together. Multiply by negative 6 and bring it up here. Add them together. Multiply by negative 6. Add them together. So my p of x, x cubed plus 3x squared minus 8x plus 60 equals my divisor times my quotient and there is no remainder on this particular one. And if you do not get a remainder, what that means is this divides this perfectly. So if we get a 0 here, then x plus 6 is a factor. And later on, when we completely factor polynomials, you're going to be using this fact to reduce polynomials of higher degree into a series of linear factors. So let's do one of those. And when we completely factor polynomials, they vary from very easy to not quite so easy. And the first thing you have to remember is we're going to have as many linear factors for a polynomial as the degree of the equation. In other words, when I completely factor this, I'm going to have 3 zeros, or 3 factors, depending on which way I decide to answer the question. So if you get something like this and they ask you to factor completely, the first thing you want to do is plug it into your calculator. So graph this in your calculator, and you should get a picture that looks something like that. And it looks like it might cross the x-axis at -1, at 3, and at 5. We can't really be sure, but it looks like it might. The next thing you want to do is go to the table function on your calculator, just hit second function and the graph button, and check out the x values at each of these points to see that the corresponding y value is 0. In this case, it is. So you're done. You know the three zeros are -1, 3, and 5. So there it is in factored form. And the zeros are -1, 3, and 5. And note, the zeros are the numbers you found here. For the linear factors, we have to change the signs on them. Let's do one that is slightly harder. Alright, so I'm asked to completely factor x to the fourth minus 2x cubed minus 12x squared plus 40x minus 32. And I know I'm going to get 4 factors. So the first thing I do is graph it. And I get something that looks like this, and it looks like maybe -4 and +2 will work. So let's see what happens when I work with those. Because if I go into the table, it will show those are zeros, so I can work with them, but that's only 2 and I need 2 more. So let's see how to get that. Let's start by pulling out the -4. So let's pull out the -4 with synthetic division. And see what happens. So I bring the 1 down, multiply by -4 and bring it up here. Add them together. Multiply by -4 and bring it up here. Add them together. Multiply by -4, bring it up here. Add them together. Multiply by -4, bring it up here. And we get a 0, which means that -4 is indeed a 0, but we knew that from the table, and that this polynomial has a factor of x plus 4. Now we're interested in reducing this polynomial to make things easier, so I don't care about any of this. I just care about what's left over after I've completed that operation. So now, just working on this, I'm going to divide out the 2. So I bring down the 1, multiply by 2, bring it up here. Add them together. Multiply by 2, bring it up here. Add them together. Multiply by 2, bring it up here, and 2 is indeed a 0. And I'm left with x squared minus 4x plus 4. And somehow I have to get 2 zeros out of this. You have 3 choices. You can factor, and that's usually the simplest. If you can find the factors, you can use the quadratic formula. Or you could notice that this graph does a little wobble here. And whenever you see a little wobble there, it's a good indicator that maybe the multiplicity is greater than 1. And remember, even multiplicity means it touches and bounces off. Odd multiplicity means it crosses. So it's crossing, it's wobbling a little bit. So I'm thinking this might be a 0 with a multiplicity greater than 1. So I'm going to check that out. So again, I'm going to ignore this. Try pulling out the 2. Let me put the factor up here. And I'm going to see if 2 is a factor of this. So bring the 1 down, multiply by 2 and bring it up. Add together, multiply by 2, bring it up. And it is indeed. And you can either do that again or realize this is just x minus 2, and that's our last linear factor. And let's just simplify that a bit. And we're done.